Okay, today is our official review day for Chapter 6. And there's a whole bunch of stuff on polynomials, polynomial long division, end behavior polynomials, etc. We're going to start with this one right here. I tried to teach you limits yesterday for the first time. This is our chance to review it. And so a lot of kids will remember this much. Lim. Will you remember the rest? I'd like you to write a left-end limit and a right-end limit. They will be different. And you know, you can't just say the limit is infinity or the limit is negative infinity. There's a lot more to it. Can you tell me one thing, Joe, that has to be in your answer? One more thing than just lim? So if I'm on the left end, that's where x is approaching what?
Negative.
Good, because the left end is like over here. Now you might be like, but that's going to positive infinity. That's not the question. X going to negative infinity signifies we are doing the left end limit. All right, so what comes after the word lim? Raise your hand and I'll try not to call on you multiple times, but I'm going to try to get everybody during this hour. So if you at some point want to just get it over with, awesome. All right, Sasha? F of x is equal to infinity is correct. That was the left end limit. All right, Neil. Right end limit, or you got a question?
The right.
Do it. And that's the right end, and then f of x, and then equals negative infinity. Can you tell me which part pertains to the x and which part pertains to the y of this?
The x is like at the bottom.
Yep, that's the x,
And the y is like x.
and that's the y. You could almost say that this point, if we continue forever, this point would be at positive infinity, comma, negative infinity. Do you get what I mean by that? Is there really a point at positive infinity, comma, negative infinity? No. But do you get how that can tell you this and that? See what I mean? All right. And this point here would have been at negative infinity, comma, infinity. Again, there is no point there, but if I was going to make up a point for it, that's kind of it. And then, look, it tells me this and this. Okay. Is that enough on limits? Do you feel like you got limits? All right. If you want, you can always ask me later for more problems about limits. Maybe I'll throw in one more later. Okay. Everybody get to this page. The Chapter 6 concepts, there's a lot of them. Standard form of an equation would look kind of like this. Y equals negative x to the fifth plus 4x squared minus 8. Would you be able to tell me the degree, leading term, leading coefficient, and the constant? Please do that for that red equation. I'll pause while you give that a shot. The leading term is super important, and that's this one, because that tells me almost everything. Who's going to be participating at this point? Michael, what does it tell you? What does this negative tell you?
Negative tells you which direction it's going initially.
All right. When you say initially, do you mean on the right or on the left?
On the left side, it's going down.
That negative actually tells you the right side. The right side is going down. All right. I know that wasn't one of the things that it was actually like asking. It wasn't asking for that, but let's go through that because this is right side. And then what tells you the left side? Nothing tells you the left side. But you can kind of figure it out from something. The right side, you find out from this negative here that it's down. The left side, you have to kind of infer it from something. Yes?
It's odd, so it's gonna be different.
So it must be different than the right side. Very good. So since the right side was down, the left side would be up. Okay. All right. But let's get through the degree, the leading coefficient, etc. Well, the leading term I highlighted there, negative x to the fifth. The degree, 5. The leading coefficient, negative 1. A lot of people say negative 1x. Nope. The coefficients are numbers. Negative 1. And the constant is that. The negative 8. All right, now what if it's in this form? And today's about review, so I'm supposed to like stretch you a little bit. Before you were just barely learning this stuff, but now what if I reverse some things? This will mess with your head a little bit. Now, that's in factored form. And at least I gave you a heads up that I was messing with you. So, figure out the degree, the leading term, the leading coefficient, all that same stuff from that factored form one. Okay, give me just a second. Now I'm gonna call on somebody else here in a minute, but I want everybody to answer this. Be ready.
Is that a 5 or a 9?
That is a 5 right there. Sorry, I'll make it clearer. It's supposed to be a 5. Pausing.
Yeah, I got 3.
All right, degree 3. Let's talk that through. Not saying you're wrong. How'd you get it though?
So you square the x on the right, so that's x squared.
Yep.
Another x on the left.
All right, x to the third is part of your answer, but then is it positive or negative x to the third?
It's negative x to the third.
It's negative x to the third, and that was critical. If you didn't catch that negative right there, that negative, when you multiply this all in, would mean the lead term is negative, which then means the right-hand side is down and all those other things. Okay, keep going. So we got the leading term is negative x to the third. What's the degree?
3,
What's the leading coefficient?
negative 1.
Negative 1 is correct, and the constant term.
I got 200 because you have to square
5 squared is 25, yup. And then
multiply that by 8.
multiply by 8, 25 times 8.
25 times 4 is 700.
Wait a minute. Yep, so did you say 400 or you say 200?
200.
200 is correct, good. Now, if you didn't get that, it'd be understandable that you might not have taken the time to multiply that up. But would you agree that the 5 squared is 25 and then eventually the 25 is gonna hit this 8. If you multiply everything by everything, the 25 is gonna eventually multiply by the 8. All right. End behavior and limit notation, we already practiced it, so maybe we'll do it on a different problem again later. Number 3, here's a problem. 3, x minus 5 to the second, x plus 2 to the third. Can you tell me the multiplicity and the behavior of the x-intercepts? I haven't heard from everybody yet, of course, so try to get your participation over with here. Tell me, what's the multiplicity of the first x-intercept?
2
All right, so you're saying that one of the x-intercepts is 5, and it has a multiplicity of 2. You are correct. Now, what does that mean about the behavior there?
It bounces.
It bounces there. And last but not least, this root.
Oh, -2.
And what would it do there?
Snake
Snake, and the multiplicity there?
is 3.
Good. Now, I'm going to add one more thing to this problem. If I throw a negative in the front, does that change any of our answers so far? No. But it would change how the graph would look. Everybody, quick sketch this graph. Would we have to do that? Yes, see, that's number 4. Sketch a possible graph of a polynomial. You should be able to be pretty accurate on this one. You know the roots. You know what it does at the roots. You know the right end behavior. You know the left end behavior. You know like everything. So you should be able to sketch this puppy. All right, I'm going to pause for a second while you give that one a try. Okay, -2 is one of the roots. I agree. Let's graph that. Here's, let's say that's where -2 is. What do I have it do there? And that was the snake because of this 3. So I'm going to write snake. Just to remind myself for later. And then the other root. What should it do there? Okay. How about the right end? I always start with the right end. Joe, you take over from here.
Are we doing this with or without the negative?
That we are including that negative there.
Alright, then starting down. Nope, I'm looking at the left. Starting up on the left. Right.
Okay, hold on. That negative in the front, it's very confusing.
Are we? I don't know. My
There-
rights and lefts are throwing me off. It's not the numbers. It's just.
All right. All right. So, pausing for a second. Answer here. All right. So this negative in the front means it's down on the right. And then it bounces there. And then since it's degree 3, 4, 5, degree 5 means they have to be going opposite ways. It would go like that. One more thing I could check is the y-intercept. Does this thing have a y-intercept? Some of you would say no, but that would mean you don't know what you're talking about. The y-intercept is where you put in x is 0. Now, it might not be nice to calculate, but you just have to put a 0 here and a 0 here, and you could figure out that there is a y-intercept. And all we really care about is if it's negative or not. This part would be 8. This part would be positive 25. Then it gets multiplied by a negative 3, and bottom line, it's a big negative number. So yeah, the y-intercept's in the right spot. Okay, questions or comments? Yes?
I think -2 is supposed to snake.
Oh, it's supposed to snake, and you're right. I just drew it really straight through there, but the fact that I wrote snake there, it probably would have saved me on the test, but I really should make it look a little more snaky. There, I made it wiggle a little more. It's a good point. But I totally get, it's gonna be hard for people to draw those. It's hard for me to draw those. And the only thing I can go back to is x to the 3rd is like the ultimate snake, and it looks like that. The point at the 0 has to be an inflection point where it goes from increasing at a decreasing rate to increasing at an increasing rate. And so it's really hard for me to draw those backwards and in strange situations. So if you label it with snake, I'll be okay. All right, any other questions about that kind of problem? I can do more like it if you want. You just have to say, can you do another one like number 4? All right, then let's use long division to find remainders. We're gonna do a simple one first. X squared plus 3x minus 4. That one factors. So I know that it would factor if I put the right thing out in front. But what if I put the wrong thing out in front and I just say x? You can still do this. It'll just have a remainder. But everybody please try putting just x in front and divide by x and see what you get. And your answer will have a remainder. So tell me how to start, Oscar.
Well, you put an x on top.
Agreed.
X times x squared is gonna be.
0 on the left, bring down a 3x. Then what?
Then you can put a 3 on top. And
3 times the x, 3x. Opposite, draw the line. Bring down the negative 4. Now what?
negative 4 is the remainder. You can't do anything.
When you say you can't do anything, I could do something. I could put an x here. But
X doesn't go into the negative.
All right. I'll put you out of your misery. I agree. It's hard to answer that question. Like, why don't you keep going? But I need to match this somehow, and I can't put anything up here so that when I multiply it by x, that it will remotely like work. Okay, so then this is a remainder. So how do you write your answer? You write it as x times x plus 3 minus 4. Notice these are the two factors, and then you put the remainder there. All right, let's try one that is significantly harder because it's a polynomial long division that should actually work. And this one, how about this? Maybe somebody smart out there who knows what I could put here that would make it work. Don't think that would work. I don't think 1 is a root. X plus what?
4.
X plus 4. I concur. Give it a shot. And if he's right, then we won't have a remainder. I'll pause for a second and give that a try. I'm going to add one more because some kids go really slow on these and some kids go really fast. I'd like to jump to the last kind of question, which has the cutouts. And let's say this is 12 and this is 5. And I want to know how to write the volume of this thing and the domain for x. So answer those two questions, and I'll unpause when we're done. Okay. Cal, I haven't picked on you yet. Tell me how to start this thing.
So first you want to put x squared on top.
Okay,
Or which one do you want?
you're correct. You're good. Yep. Actually, though, you know what would be really smart? If I answered this one first, and then I can erase it, and it'll make room to do that other one.
Okay.
So how about that? Could you tell me the volume of that one?
Yeah, so the volume is going to be 5 minus 2x times 12 minus 2x.
Yup. Why 2x? A lot of kids just think, I don't get, if I'm going to subtract off x from the 12, why isn't it 12 minus x?
Because then if it's 2x, or then it'll be bigger than the side. Or like so there's two sides, so then there's going to be,
Yes, I like that explanation better. There's two sides you're going to cut off. And there's two x's therefore, this little x and this little x. So 12 minus 2x. Okay, keep going, and there's one last thing.
yeah, and the domain's going to be from 0 to 2.5.
All right, agreed on that. And as long as you do your parentheses and brackets right.
Parentheses 0, comma 2.5 parentheses.
And why do you think I get a lot of 0 to 6 for this answer, but it's wrong?
They took half of the long side.
All right, good. Why can't it have brackets? Know why? Hannah?
Is it because it has to be less than?
Yes.
X has to be less than.
It has to be less than the 6. Can't be, well, in fact, can't be 6 at all, but 2.5 has to be less than 2.5. Because if it was 2.5, do you get how it would take up this whole side? 2.5 and 2.5, and then this side's gone. It just disappears. Okay. All right, I'm missing one thing from this formula. Cal,
Oh, x.
all right, good. And what was that last dimension? Where'd that come from? Like where in here?
The side of the corner.
Okay, and when you fold it up, this side, you fold it up, it turns into the what of the box?
The height.
Yes, it turns into the height of the box. So that is length times width times height, domain. Any questions about that part? Okay. LeBlanc, can you do the long division? Did it work for you?
Yeah,
Excellent. So tell me, I start with an x squared, is it?
yeah.
Then what do I do?
And then you put the opposite, well,
Hold on, tell me what to do with it first.
Multiply it by the x.
Okay, so what do I get?
X to the third. And then plus 4x squared. But then change both sides.
Good, do, and then what?
You get 0.
Good, then what?
Bring down the 2x plus 8.
Why'd you bring two things down? Sometimes we only bring one thing down, but you brought two things down.
Because there's 2 terms.
Yeah, there's two things here, so there should be two things there. Okay, good. Last little piece of the answer.
And then you add 2.
And then I multiplied it back out, and I get 2x plus 8. Opposite, opposite. There's 0 remainder. And here's the hard part. What if I had said, what are the roots of this? You might be like, well, I factored it. Isn't that good enough? Doesn't answer the question, what are the roots? Take a minute and figure out what the roots are. I'm going to pause for a second while you do that. So -4 for this one, and then this, you're setting it equal to what? How about if I say it's equal to 0, and then I subtract 2 from both sides? Would you be okay with that? Okay.
And then square root both sides. And then absolute value of x
Nice.
equals square root of -2.
And I'm changed it to that. Did you ever change it to that?
I was gonna do that.
Good. I just saved a step. Now what?
And then x equals I square root of 2, and the x equals -I square root of 2.
How many roots did I have? -4 was a root. This was a root. This was a root. 3 of them. Why is that logical? Because the problem was an x to the third. There should be 3 roots. But how many of them are real? Noah? All right. 1 real, 2 imaginaries. All right, then write a polynomial based on a description of characteristics, like the x-intercepts or a leading term. All right, so here's my description. This graph will be down on the right, up on the left, have a double root at 8. What's your equation? There's more than one right answer. Now remember when I said this before, it was like, if you're building a house on the side of a mountain and you just told the builder, I want it to have a really nice deck and a hot tub. Could the builder put in more things too? Like maybe a bathroom, maybe stairs to get to it? I mean, they're going to put in other things. But my only requirements are it has to have a nice deck and a hot tub. Well, here, you're going to have to put in other things to make it do all of this. But it has to at least have that, that, and that. And I also said there was an infinite number of answers to this. But that doesn't mean everything is right. So imagine I'm the kid you graded, and I said this. I get, some people probably did. What would you say to me? Tasha?
You're wrong because it has to go up on the left, which means it has to have an odd definition.
Why? Mine goes up on the left. Just because the kid says it with a lot of conviction doesn't mean he's right. How do I know mine doesn't go up on the left? I thought mine does go up on the left because it's going down on the right. Why isn't mine going up on the left? I say it is. Joe?
Well, for one, your double root is at -8.
I got all kinds of problems. Okay, okay, now I believe that part, but now it's right. No, it's not.
No, it's not. Well, I was
So tell me this. Thank you for fixing that part. Put something with my answer that makes it right, Joe.
X plus 1.
Like this.
Yeah.
Why does that make mine answer better?
Because it has an odd degree, it has the opposite degree.
All right, so it has an odd degree, which will lead to what happening?
It going up on the left, right. It's going up on the other side.
It goes up. Oh, nice, good save. All right. Coping strategies for.
I don't know my life.
Where were you?
That's down on the right,
No, I get it.
and this will be up on the left. All right, nice work. So, I feel like you guys will be fine at that. And now, the nastiest thing. Long division when it doesn't work out nice. X to the 5th plus 3x squared minus 1 when divided by, oh, let's keep it somewhat simple, just x. What's the remainder when you do that? Are correct, so keep going. If I put an x to the 4th, I multiply it there, I got x to the 5th. Opposite, 0 left, now what?
Then I moved down 3x to the second.
Okay,
And multiply 3x.
so I'm gonna put a plus 3x and then 3x squared and then opposite. And this isn't that hard, Mr. Server. That was no big deal, right? Okay, so then what was my answer? X times x to the 4th plus 3x and then minus 1. Did you factor it all the way? What? What are you talking about, Mr. Server? Well, anybody notice anything about that? What could you do with that? Yes.
You can, factor out a x,
And then you'd have what left?
you x to the 3rd plus 3.
And then a minus 1. Oh my gosh, why does that matter? Well, you want to factor things all the way. You want to factor it all the way out. So here's how that could burn you. Let's say you had this, and let's say that you had, and then let's say that you had, and you write that out as your completely factored answer. And they had even given you a tip that 7 was a double root. What should have been the first clue that you were wrong? Yep.
You only have one root with 7.
Yeah, that's not a double root. So where am I going to get the other one, Mr. K?
From the x squared minus 49.
Because that factors to, close. There you go. And now I've got two of these after all, so they could go together. X minus 7 squared. That means it was a double root. And then that x plus 7 goes down here. So bottom line, you should factor your stuff all the way out. Okay. So, gotta see. Yeah, we did do one like that with a negative inside it. Yeah, I'm feeling like you're gonna be okay, but time will tell. So your assignment, there is a worksheet. That worksheet has a lot of really good practice problems on it and an answer key. So that's your homework for tonight. There are a few of you with a 0 on the Schoology quiz. So I'm gonna leave you to, the rest of the time is you studying for this test. That's all I got for the video for today.